So in this video we will discuss about insertion sort, and insertion sort is a stable sort algorithm as we know, and it is also in place sort algorithm. So what does mean by the stable sort algorithm? So stable sort means that stable sort algorithm are those algorithms which maintain the relative order. Stable sort, let me write it down. Stable sort means algorithm which maintain relative order of the elements. Maintain relative order of elements. Let's say we have an example like 2, 1, 3, 1, 5, 4. Now we want to sort it. Now when we will sort, then it will be like this. Okay. Now in the sorted array, as 1 and 1 both is equals to 1 only. So which one is representing which one? Okay. So in stable sort, we know that the relative order of the element is maintained. That is, if this one is presenting before this one, so this in the sorted array also this one will comes first, and this one will come after this one only. Okay, so in this way, relative order of the element is maintained in a stable sort algorithm. So algorithm sorting algorithm is maintained. This property is called the stable sort algorithm. What does it mean by the in place sort? In place sort are those algorithms which takes order of one space, that is constant extra space. It do not take extra space, so it is an in-place sorting algorithm. So a sorting algorithm which does not take extra space are called the in-place sorting algorithm. So how the insertion sort algorithm is work? Let's discuss the pseudocode first or algorithm. So initially we set the I is equals to 1. Okay. Currently I is equals to 1. We will check if I is smaller than n. This condition is checking whether I is reached to the end of the array or not. So initially we are at the beginning of the array. Okay. So when this condition is when this condition is true, then we will move forward and we will set j is equals to I. That is, when I is equals to 1 initially, then j will be set to 1. So and key set to the array of I, that is element at index 1. Okay. And now we will move to the loop of j, and we will check if j minus 1 is smaller than equals to 0 or not. Okay. And the second condition, we will check if element at j minus 1 is greater than key or not. If it is not greater than key, then we will not do not enter into the j loop, and we will simply increment I, and we will copy the key to jth location, and again we will uh, check the condition of I, and we will move this loop only into this loop only. Okay. Whenever we will find the any element which are greater than key, then we will simply decrement j, and we will copy the element at j to its next location, and again we will evaluate the condition whether j minus 1 is greater than 0 or not, and element at j minus 1 is greater than key or not, and again we will do the same task. Okay. So this flowchart will be clear when we will discuss the algorithm. So let's discuss the example, then we will have the understanding of the working of the algorithm better. Okay. So let's say we have number 6, 4, 1, 3, 2. Okay. let's say 5. Yeah. So initially I is equals to 1. So I is not greater than n, it is smaller than n. N is 6 here. So key will be set to array of I. Key is set to array of I, that is 4, and j is also start from I. You can see in the flowchart. When I is, we will find that I is smaller than n, then j will be set to I and key will be set to array of I. Uh-huh. So j will be here. Now we will move forward. As we will move forward and we will evaluate the condition on j, that is j minus 1 is greater than equals to 0 not. So j minus 1. 1 minus 1 is greater than 0 or greater than equals to 0. This condition is true. And array at j minus 1, that is 6, is uh, greater than key or not. Key is 4. So it is greater than key. So will 6 will be copied to jth location. So 6 will be copied to here and j will be decremented by 1. So j will be decremented by 1. So j will come here. And we will again evaluate the condition j minus 1 is greater than equals to 0. No, 0 minus 1 is minus 1. That is not greater than equals to 0. So condition is false. Condition is false, then we will increment I and will copy the key to array of j. So currently j is equal to 0. So we will copy the key, that key is equal to 4. Key is equal to 4 to 0th location. So 4 will be copy here and I is incremented by 1. So I will be incremented by 1. So I will come here. Okay, now again we will set key is equal to array of I. So key will be 1 now and j is also I is equal to 2. Okay, now we'll check j minus 1 is greater than equals to 0. So 2 minus 1 is equal to 1, greater than equals to 0. Yes. And array at j minus 1, that is 6. 6 is greater than equals to 2. Yes, it is greater than 6, greater than key, that is 1. So 6 will be copied to here and j will be decremented by 1. So come j will come here and again we will check j minus 1 is greater than equals to 0. 1 minus 1 is greater than equals to 0. Yes. And j at array element at j minus 1, that is 4 is greater than key. Yes, it is greater than key. So 4 will also be copied to here. So 4 will be copied to here. So and 4 will copy here and j will be decremented by 1. So j will comes here. So 0 minus 1 is greater than equals to 0. No. So we will increment. So the condition is false. So we increment I and will copy key to jth location. So we will increment I and copy key to jth location. So key is equals to 1. So key will come here. Okay. And key is now j is also 3. Now j minus 1, 3 minus 1, 2 is greater than equals to 0. Yes. And the element at j minus 1 is 6. 6 is greater than equals to greater than key. Now key is 3. Now key is 3. So 6 is greater than 3. Yes, it is. So 6 will be copied here. So 6 will be copied here and j will be decremented by 1. So j will becomes 2. Now j minus 1 is 1. 2 minus 1 is 1. So 1 is greater than equals to 0 and 4 is also greater than 3. So 4 will be copied here. 4 will be copied here and j will be decremented by 1. Now we will check j minus 1, that 1 minus 1 is 0, that is greater than equals to 0, and 1 is greater than 3, no. So condition false, then we will increment I, then we will increment I becomes 4, and we will copy key to jth location. Okay, now I becomes 4, now j start with 4. Now j minus 1, that is 4 minus 1 is 3, and 3 is greater than equals to 0, and element at j minus 1, that is 6, is greater than. Now key is also changed to 2. So 6 is greater than 2, yes, so 6 will be copied to here, and j will be decremented by 1. So 3 minus 1 is greater than equals to 0, and array at j minus 1, that is 4. 4 is greater than 2, so 4 will also be copied here. 4 will be copied to next location, that is here, and now j will be decremented by 1 again. Then now j is becomes 2. Now j minus 1 is 1. Also 1 is greater than equals to 0, and 3 is also greater than key. So 3 will also move forward or will copy to the next location. So 3 will be copied here. 3 was also, and then j will be decremented by 1 again. Now j 1 minus 1 is 0, which is greater than equals to 0, and 1 is greater than 2, no. So we will increment I, I, and copy the key to current j, and current j is 1. So current j is 1. So 2 will be copied here. Now again j will start with I, that is 5. Now we will check j minus 1, that is 5 minus 1 is 4. 4 is greater than equals to 0. Yes, it is greater than equals to 0. And then we'll check if 6 is greater than key. Now key is also become 5 now. So we will check if 6 is greater than 5. Yes, it is greater than 5. So we will copy 6 to next location. So 6 will be copied here, and j will be decremented by 1. So j will become 4. Okay, now again j minus 1, that is 4 minus 1 is 1. 4 minus 1 is 3. So 3 is greater than equals to 0. But element at j minus 1, that is 4, is not greater than 5. So again I will be incremented. Again I will be incremented. I will be incremented, and key will be copied to the current j. Key will be copied to the current j. So key is 5. So 5 will be copied a. Okay. Now when I is become 6, then this condition, that is I is smaller than n, will become false. So it will terminate the algorithm, and the algorithm will be stopped, and we will get our array sorted. Now array is sorted now. Okay. So this in this way algorithm works. If you did not understand the algorithm, then you can rewatch the video, and you will understand it. Okay. Now discuss the time complexity of this algorithm. So when I was initially 1, so j also started with 1, and j was decremented by 1 until it do not reaches to 0. So in worst case, j will start with 1 and will decrement it until it do not reach to 0. So it will run for only one time. When I will be 2, then j will be restart from 2 and will run for 2 times until it do not reach to 0. It will run for 2 times. Similarly, when I switch to 3, then j will be run for 3 times. When I switch to 4, then j will run for 4 times, and so on. When I switch to I will be n minus 1, then j will run for n minus 1 time. So in this way, total time complexity of this algorithm will be 1 plus 2 plus 3 until n minus 1. So it is nothing but n minus 1 into n upon 2. It is order of n square. Okay. So this way, this algorithm works. Now, what is the best time complexity of this algorithm? So let's discuss the best time complexity. Consider we have sorted array, and now we are applying the insertion sort to this algorithm. Initially, our I square was 1. J will also start with 1. Now j minus 1, that is 1 minus 1 is equals to 0, which is greater than equals to 0. But element at j minus 1, that is 1, is not greater than key, that is 2. So condition is false, and simply I will be incremented. I will become 2, and j will also start from 2. Now again j minus 1, 2 minus 1 is greater than equals to 0, but array at j minus 1, that is 2, is not greater than key. So condition false, and I will be increment. I will be increment to I is equals to 3, that is here. Now I will j will also become 3. Now same thing again happen. 3 minus 1 is 2, which is greater than equals to 0, but element at j minus 1, that is 3, is not greater than key. So condition will become false, and I will then again will increment it to 4, and j will become 4 again, and 4 minus 1 is equals to 3, greater than equals to 3, but array at j minus 1, that is 4, is not greater than 5. So again I will be incremented to 5, and when I become 5, then the uh, algorithm will be stopped. So in the sorted array, when I was 1, then j run for only one time. When I is equals to 2, then j run for only one time. When I is equals to 3, j run for only one time. In this way, when I will become run n, then j will run for only one time. So in this way, total time complexity will be 1 plus 1 till n times. So it will be n only. So so time complexity will be order of n. So best time complexity for the insertion sort is order of n. Now discuss the code also. So it is a C++ code. We have taken the vector and n is equal to 6. Currently I is equal to 1, and when I is smaller than n, j will be start from I, that is initially 1, and then key will be array of I, and when j minus 1 is greater than equals to 0 and array element at j minus 1 is greater than key, then we will copy the element present at array of j minus 1 to jth location and will decrement j, and it will and this loop will run until we do not reach to j is equals to 0. Okay, so after After this loop terminate, we will copy the key to the current j, and again I will be incremented, and I condition will be checked whether I is reached to the end of the array or not. And in this way this algorithm will work, and at last I have printed the array whether it is sorted or not. So we can build the code again. We will check that output is correct. We are getting 1 to 6 number which are in sorted order. Okay, thank